Welcome back to the Cyber Strategix Networking Fundamentals course. In Module 1, we learned what a network is. Now Module 2, how does data actually find the right device out of billions? The answer is IP addresses. Let's demystify them together. Think about how physical mail works. A letter can't reach you without your address. Networks are exactly the same. Every device needs an address so data knows where to go. That address is called an IP address, and understanding it unlocks most of networking. Here's the plan. What an IP address is, and the two versions, IPv4 and IPv6. The crucial difference between public and private addresses. What a subnet is and why we split networks. And how devices get addresses automatically with DHCP, plus a first look at ports. Let's dive in. An IP address is a unique number that identifies a device on a network, just like a home address identifies your house. The version you'll see most is IPv4, written as 4 numbers separated by dots, like 192.168.1.10. Each number ranges from 0 to 255. The catch: there are only about 4 billion IPv4 addresses, and we've run out. So IPv6 was created, a much longer format with a virtually unlimited supply. For now, just know both exist and do the same job, naming a device. Here's a distinction that confuses many beginners. A private IP is used inside your own network. Your phone, laptop, and TV each get one, like 192.168.something. These are reused in millions of homes and can't be reached directly from the internet. A public IP is the single address your internet provider gives your whole home. It's your identity on the wider internet. Your router sits in the middle, translating between the two using a process called NAT. Private inside, public outside. As networks grow, you don't want every device in one giant pool. A subnet, short for subnetwork, splits one large network into smaller, manageable sections. A subnet mask, you'll see 255.255.255.0 a lot, is the ruler that decides which part of an IP address names the network and which part names the individual device. Why bother? Subnetting reduces congestion, keeps traffic organized, and, this matters for security, lets you isolate groups of devices so a problem in one area can't spread everywhere. Don't worry about the math yet. Just grasp the idea. Subnets are neighborhoods within a city. So who assigns all these addresses? A service called DHCP, Dynamic Host Configuration Protocol. When you connect to Wi-Fi, DHCP automatically hands your device everything it needs: an IP address, the subnet mask, and the address of the gateway that leads to the internet. It leases the address to you for a while, then can reuse it later. This automation is the reason networking feels effortless. You connect, and it just works. Behind that simplicity is DHCP doing the paperwork. One more piece: ports. If an IP address is the building, a port is the apartment number. A single device runs many services at once: web, email, file sharing, and ports let them share one IP without mixing up traffic. Web browsing uses ports 80 and 443. Email uses 25 and 587. Secure remote login uses port 22. We'll go deeper on ports in Module 4, but for now, IP gets you to the device, the port gets you to the right service on it. Let's crystallize the big idea. The IP address finds the right device out of billions. The port finds the right service on that device. Together, those two numbers mean data always knows exactly where to go. That's the addressing system the entire internet runs on. Let's lock in Module 2. An IP address uniquely identifies a device. IPv4 is the common format, but it's running out, so IPv6 is the future. Private IPs live inside your network while a public IP faces the internet. Subnets split big networks for organization and security. DHCP assigns addresses automatically, and ports route data to the right service on a device. Solid foundation. That's Module 2. You can now look at an IP address and understand what it means, how devices get one, and how ports fit in. Next, we zoom out to see the layers that carry all of this, the OSI and TCP IP models. See you in Module 3. That's Module 2. Subscribe to Cyber Strategix to keep the course going. In Module 3, we tackle the famous OSI and TCP IP models, the layered map that explains how everything you've learned fits together. See you there.